Hi, my name is Matthew Yahov, and today we're going to talk about load balancing using Versa VOS system. So first of all, Versa operating system allows you to do a lot of different features. You can see only some of them on the screen, and today we will talk specifically about the ADC, and let's review the problem. So the problem might be when we have internet, we have certain internal server with the application, and we have the gateway device, which allows the users from the internet access service in the internal LAN zone or in the DMZ of your company. When there is like a simple one connection from the external user, there shouldn't be any problems. When you have like two maybe connections and so on, that's also not going to be a problem. But there might be cases when the number of connections might become overwhelming for your internal servers, and it's going to be hard for this application service to process that many requests. In this case, one of the solutions how to address this kind of problem is to do a distributed system or so-called scale-out system, when you will use multiple servers to serve the same purpose. So you will just distribute your application among multiple servers in your internal network. So in this case, when there's going to be one request, it will be load balanced to one of the servers on the internal network. The second request from another customer will be balanced to another service in the internal network. And the third one will be load balanced to another one again. And this all will happen using the load balancing or ADC service on the Versa device, which is embedded and technically available with any license which comes with the system. And the interesting thing here that external customers, they will not know that they're load balanced across multiple servers. They will all think that they're connecting to the same single IP address which belongs to the VOS device, which is the gateway router for your internal network. So let's review in a little more details how do we configure all this. So first of all, you need to enable application delivery controller. For this, you would need to go in the others service node groups, add the ADC service to be available on your VOS device. This will only enable it globally and will allow us to enable it for a certain tenant. So the next step is to enable ADC for a specific tenant where it should be available. For this, we will go to the others limits tenant, select your tenant, and in the services menu you will add the ADC service. In this case, and only after this, you will have the ADC available for that specific tenant where you want to configure it. So next, we would need to define internal servers. As an example, previously we had 3 servers internally. You can have as many servers as you want, so technically there is no limit on the number of internal servers. But you need to define them all. So for this, you would need to go into the services menu, ADC load balancer, and in the servers, you define what is going to be your internal server. So first of all, you define the IP address over the internal server, what should be the port number of the application to which we want to have access, and through which VRF it is available. Please note, you cannot specify like ICMP protocol or something like that. Only TCP and UDP are available, so you can select either TCP, UDP, or any of those two. We will cover the monitor section a little later, so for now let's just go to the next step. So after you define servers, individual servers, you need to create a group just to identify how and between which servers we're going to be doing the load balancing. So in this case, I'm defining only one group, which is called server group 1, or pool of the servers, and I am adding multiple servers in it. You can specify the ratio in which the connections will be load balanced. By default, they're all equal, but if you want, you can specify, for example, 5, 1, 1, and in this case, 5 connections will go to the first server, 1 to the second, and 1 to the third, and then it will repeat, and again, another 5, 1, 1. You can specify any ratio you want. So also you can specify the load balancing algorithm. So those can be just a basic round robin, weighted round robin based on the ratio, because without ratio it will not work. To put the connection on the server which has the least connections in the current moment, and many other options available in here. So after you defined your server pool, you can define the external IP address on which we will be listening for that connection. For this, we would need to go in the services ADC virtual service. In the virtual service, you will define the name of the load balancer. So here I'm just defining it as the external IP. You can specify what should we listen for TCP, UDP, or for both of them, what is the external IP on which we're listening, and the port on which we're listening. And where should we load balance this to? Here we define what is the group to which we're load balancing. And after that, after you click OK, the load balancing configuration is done. We're all set. So let's try to do the configuration on practice. On practice, we're gonna have this topology where we have branch A, which has the external IP address 192.168.122.231. We have 3 internal servers, server 1, 2, 3, with the IP addresses 10.10.10, 100, 101, 102, and we have external user which is connected to the same switch as the branch A, or it can be just connected to any internet location just to have access to that external IP. Next, let's go and do the configuration on the Versa director. Okay, here's my Versa director. Here I have a couple of templates. The one which we will be using today is standalone 1 WAN 1 LAN. In this template, first let's enable ADC. For this we're going to the others, services, service node groups, and we are adding the ADC in the list of available for this box. Next we're going to go in the limits and enable it for a specific organization. So for this organization we will add that it's going to be an ADC. Third, let's go and configure ADC or load balancer itself. So in the services menu, in the ADC, we will go and configure 3 of the servers. So let's add them. Server 1. Okay, let's just do it any. The internal IP address is 10.10.10.100. Let me double check. Okay, 100, 101, and 102. Let's try to do this for the SSH service. This way we will see where we connect, which of the applications and which of the servers when we log in. Now, this internal service is located in the LAN VRF. So we're gonna specify LAN VRF and let's add 2 more servers. So server 2, IP address 10.10.10.101, port 22, and in the LAN VRF. And lastly, server 3, the IP address 102, port 22, and the LAN VRF. Okay, we defined 3 internal servers to which we will be doing load balancing. Now, let's group them into one single pool. So we'll say it's server pool 1, server 1, server 2, and server 3. We will leave the load balancing method as the default, just to do a regular round robin without any waits, for the sake of simple demonstration. We defined the pool, and now let's define the virtual service. The virtual service, so let's say loads balancer 1, type for all type of traffic, external port 22, and the external IP on which we listen is going to be 192.168.122.231, 192.168.122.231. Okay, the pool to which we're load balancing connections from this IP and this port is going to be this pool. Okay, and lastly, we need to specify in which VRF we're listening for this for the connection to this IP address. So we're going here and specifying that it's going to be in the Internet Transport VRF. And let's actually enable logging to the default profile. We're listening on this IP address in the Internet VRF on this port. And we will be load balancing this to the internal servers from the pool server pool 1. So let's say OK. And now let's commit this template with the configuration to the actual branch. Okay, now let's do verification. So for this, we're gonna go in our lab, open console connection to the external client. And now let's try to do SSH. SSH to the 192.168.122.231. Okay, we are connecting. And we got into server 3. Let's try to open another connection. So I'm going to open another terminal window. And let's try to connect to 192.168.122.231. And again, server 3. And let's try another one. And look at this. We cannot connect because in our SSH known keys, we know that the external connection has a certain cipher. So now we were load balanced to another server. So let's just temporarily remove from our SSH connection the known hosts, and let's try to connect again. Look at this. We were load balanced to the server number 2. And if we'll try to do this a couple more times, we will be load balanced every time to a new server, and every time new. Now, we just saw that we are connecting to the same IP address and we're being load balanced to different servers. Now let's see how do we verify the work of the ADC from the GUI. So first of all, we're gonna go back. Let's go to the monitor, devices branch A. In here in the branch A, we will go to the services. In the services, we will open ADC and we will see load balancer. So first of all, we have load balancer 1, which is listing on this IP address, on this port, in this VRF. The current state is it's enabled. Monitor. How do we monitor something? We didn't define monitors yet, so that part we will come a little later. Servers. We have 3 servers, and currently we have a couple of connections to server number 2. We have a couple of connections to the server number 3, and that's how it works. And we can see some other statistics, whether it's enabled, disabled, current connections, and so on. So in the virtual service, you can see a little more statistics about what is happening with the internal servers and how do they work or not work. So this basically it for the basic configuration of the load balancer. Now, what I told you previously about the monitoring, for example, each of the internal servers by default are monitored by the ICMP probes. So as soon as we stop monitoring certain devices as the if, for example, the service like SSH or web service is down on that server, but we are still monitoring only ICMP, we'll never find out whether it's actually being down, the service is being down or not. So if we want to monitor not only the reachability of the internal server, but the reachability of certain service on it, like TCP port, we can enable special monitoring service in the configuration of the ADC. Let's see how to do this. So first of all, we're gonna go back in the template. In the services ADC monitors, we will create a new monitor. So this will be TCP port 22 monitor. So we're gonna say that we want to monitor using TCP. Here we will specify the port we want to monitor is port 22. And also here is the definition of how we monitor. For example, how frequently we're sending probes. By default, it's every 5 seconds. Now, how long do we wait for the probe to be considered as timed out? So let's make it 2 seconds. And how many retries needs to be lost? Or how many times do we need to retry the probe to consider that service as down? Let's say it's going to be 2. And the last parameter, downtimer. Downtimer is for how long minimum the service will be considered down if it went down. So just to avoid constant flapping of the service. So we're going to say OK. And now we need to attach this monitor to different servers. So for example, we're going to attach it to server 1. We're going to attach it to server 2. and we will attach it to the server number 3. Okay, and let's commit our template. Okay, template committed. Now let's do verification. So if we're gonna go in the monitor, in the appliance, and in the ADC, first of all, we see that we have the new monitor, which was customly defined, and it's called TCP port 22. So we have multiple bindings, and here it shows how many probes we are sending. So these numbers are constantly going to be updated. Now, if we will check servers, like 1, 2, and 3, currently all of them are in the up operational state. They are enabled, and this is all because they are available and they are being constantly monitored by the probes. Now let's see what will happen if we will disable SSH service on any of those servers. So let's say we're going to the server number 1, and we will log in. Okay, here it is. Sudo service SSH stop, and the SSH service is stop. So technically, by the way how we configured the monitor, we should wait up to 15 seconds for the service to be considered down by the monitor. So let's actually go in the GUI, and in the GUI we'll go in the virtual service and we'll return to the server. And we see that this server is already considered as down. So meaning that we will not send any more load balancing requests to this server, and everything which will be load balanced only across these two. Also, if there were already existing sessions which were connected to this server, they will be redirected to other two services. So this is kind of very important thing, that we're not only doing excluding the server from the list, but we're also failing over the existing connections from the server to the other two. Okay, next, let's review the topic about high availability. In the Versa ADC load balancer, we can define availability groups. For example, we can select a certain number of the application servers which are gonna belong to the active server pool, and certain number which will belong to the backup server pool. This might be done for a couple of reasons. One of the most common one is when you have one application which is listening on the port, let's say 22, which is load balanced across two servers, and another application which is listening, for example, on the port 80, and it needs to have a dedicated server which is not interfering with the first pool. So in this case, you will just load balance the traffic from the port 22, for example, on the first two servers, and from the port 80 on the third server. But if, for example, server 1 will fail, we will fail over to the server 2. If the server 2 will fail as well in the active server pool, only then we will fail over to the actual backup server. So in this case, both of the applications will be residing on the backup server. Once again, in majority of the cases, this is happening when you need to just dedicate certain resources for the normal operations for the certain applications. Sometimes it's also happening when you put certain servers in one data center and another number of servers in the backup data center as well. This is possible in this case as well. So let's review how this is possible to configure. First of all, we need to return the SSH service. So let's make it active again. Okay, so now let's go and do reconfiguration in the Versa director. In the configuration, here's our template. And in the ADC, so initially we configured server pool, which was server pool 1, and let's make it server pool, let's remove actually server 3 from that pool. Let's assign the server 3 to the backup server pool. And server number 3. Now, when we configure the load balancer, the virtual server of the load balancer, we can specify what is going to be our default pool, which is going to be used by default when all the members of that pool are active and working. And here we can define the backup pool. And there is also a knob to fail back when the default pool, or at least one member in the default pool, becomes active again. So we can set it as well. That's it, configuration is done. This finalizes our video. I hope this was informative for you, and thank you for watching.